Welcome back. It's officially winter. We've made it, but have you wondered why we actually get cold?
Well, UFI professor Paul Kwiat tells us about the second law of thermodynamics in today's Wise Guys Wednesday. Take a look.
Good morning, everyone. Nice to see you again. I hope you're all doing fine as the holiday approaches. Last time we were talking about this forehead thermometer and how that works, and we said, well, it's got a little infrared sensor at the top, and it uses the fact that anything that's warm will emit thermal radiation, electromagnetic radiation. For something that's around my temperature, that will be in the infrared, which is why we need an infrared sensor. I'm going to try and explore that a little bit more, that radiation and maybe why it's interesting. And to that end, I have this cool toy, one of my favorite ones. This is a thermal imaging camera. So there, you can see what it sees now. So those are my my hot little hands, and that's my face and my cool glasses. The plastic actually blocks the infrared, which is why it shows up dark. So as I say, anything that's warm will be emitting thermal radiation, and I can also transfer thermal energy in other ways. So for example, by touching something. So let's just see a kind of a fun demo of that. I just need to reorient my camera here for just a second. Okay, so now this is my stovetop. And again, this is my hand. And here's the camera, thermal camera. And I'm just going to touch my stovetop with my hand. And you can see when I pull my hand away that the fingerprints are still showing. And that's because I transferred some thermal energy into the stovetop. But you can also see that the energy is dissipating. So the temperature of those fingerprints is going down to match the rest of the stovetop. Now, that happens pretty slowly because of the fact that because it's my stovetop, I don't want the temperature to change very quickly. I don't want the energy to flood throughout the whole stovetop. I just want it to be centered on the burners. So this is instead a cookie sheet, a metal cookie sheet, and I'm just going to do exactly the same thing here. And with the cookie sheet, yeah, you can hardly even tell because the energy spreads out so quickly. So this is the question. Why is it that the energy spreads out? Why does that happen? So it turns out that that's due to the second law of thermodynamics, which says that the total entropy of a system can never decrease. It can only increase. So what is the entropy? The entropy is basically the amount of disorder that's in a system or the number of ways of configuring that system. So let's say I have a hot cup of coffee and it's in the room here. So this has some entropy. The room has some entropy. The room probably has certainly a lot more entropy because it's a lot bigger. In order for the coffee to cool down, I have to take energy out of the coffee cup and put it into the environment. And it turns out that the change in entropy is equal to however much energy I take out divided by the temperature. So because the coffee, when I'm taking energy out of the coffee, that's going to reduce the entropy of the coffee. And when I'm putting energy into the environment, that's going to increase the entropy of the environment. But because initially the environment is at a lower temperature than the coffee, what's going to happen when I take the energy out of the hot coffee and put it into the environment is the entropy of the environment is going to go up, but it's going to go up more than the entropy of the coffee cup is going to go down. So the total entropy, which is the sum of the coffee cup entropy and the environment entropy, the total entropy is going to go up. And that's going to keep happening. The energy is going to keep leaving the coffee cup and going into the environment, increasing the net entropy until they're at the same temperature. And once they're at the same temperature, then when I have energy that would move from the coffee cup to the environment, the increase in the environment entropy and the decrease in the coffee cup entropy would be exactly the same. So you wouldn't be getting any more net increase. And then things are basically going to stop. So things are always going to move. The energy is always going to try and redistribute itself until things are at the same temperature, because that will maximize the total entropy. And once that happens, then the whole process is done. So there's never going to be a spontaneous heating of this coffee cup or a spontaneous cooling of this coffee cup. And in fact, we'll maybe rely on that next week for something else. So what does that have to do, though, with our forehead thermometer? Well, one of the things it says on the instructions for the forehead thermometer is you shouldn't use it right after you've come in from being outside. So why is that? So if I've been outside in the cold, the skin, my skin, will cool down, will give up energy to the environment, because that will increase the total entropy by lowering the temperature of my skin. So when I come in, the temperature of my skin is going to be low, and then when I try and get a reading with this, I might get a false reading. So I want to just demonstrate that here. So I've been wearing an ice pack here for a few minutes, and I'm just going to take that off. So that's to simulate my being outside, and we can now use the forehead thermometer, now a wrist thermometer, to see what the temperature is. And in fact, at the moment, it's even below the what this thing can register. Give my hand just a second to warm up a little bit. I've cooled myself too much. There we go. Okay, so there the temperature is only 90.1. That's when the thermometer starts to work. Now it's 90.3. Now it's 91. Oh, there we go. Now it's even higher. So you can see over time that my skin is going to warm up more closer to obviously to my body temperature. And again, the reason that's happening is the energy is flowing from inside my body to my skin to try and make everything at the same temperature, according to the second law of thermodynamics. So it's increasing the entropy. Okay, so obviously you didn't need to know that to understand how a forehead thermometer works. Anyway, I thought maybe it was a little bit fun, and we will use some of this next week when we have the final conclusion on this. And I try to convince you that it's actually amazing that it works at all, and that will reveal a deep property of human nature. Okay, hope you guys have a great holiday, and I'll see you in a week. Bye-bye.